In this video, we are going to learn how to find an equation for a sinusoidal graph. Now, I'm going to start off with an example here with this wave function that goes as high up as 3 and as low as -3 and counts by each point by about a fourth. So we're going to first identify what the amplitude is. We can find that a value that usually goes in front of the trig function. Now, I just mentioned that it goes up as high as 3 and as low as -3. So this wave that goes up 3 and then down 3, that is the amplitude of how far it reaches. So the amplitude of this function is 3. So that pretty much goes to say that a is probably 3. The way we double check this is we first pick a trig function to use. So in this case, this 3 would multiply by the key points of either sine or cosine. Now the first point for sine is usually at 0, so 3 times 0 wouldn't be +3, but cosine usually has 1 as its first value, and 3 times 1 is 3. So when I go to write my function, y is equal to, this a value should be 3, so this will be 3 times cosine of something to account for the amplitude change. Again, using cosine because it doesn't start at 0. This next example we'll see in a little bit that does start at 0. This will probably be a sine function. But this will be cosine since I'm starting at a value other than 0. Now next thing, I figure out the period. Now the period is how long it takes to go through one whole cycle. So from one peak to the other peak, we'll start up here. From here all the way to here has a length of 1. So from 0 to 1 is 1 in length. So that period is 1. So if I know that the period is 1, if I set that equal to 2 pi over omega, then I can solve for that w value that would typically go in front of that cosine function. And I'll even rewrite the general form that we talked about in the last lesson. We figured out what a was. Now we figure out what this omega is. So I can figure this out by multiplying each side of this equation by w, giving me w is equal to 2 pi, and I'm already done. So omega must be 2 pi. So I'll put 2 pi x. And that is how you find an equation for a sinusoidal graph. Just break down its components and translate that into the function that we know as amplitude and period. Now I'll do this one more time. This function we just talked about earlier, it's just probably a sine function since it goes through the origin like this. So I'll put down the general form here. We need to find a and omega to finish off this problem. So the amplitude of this graph, looking at it, looks like it goes up 2 and down 2. So the amplitude is 2, but the a value in this case is going to be -2, since usually the first key point is at +1, but now it's at -2. It's probably being multiplied by -2. So again, we find that a value by identifying where the key points originally were and then seeing what we multiply them by to get to that new value, which is at -2. It used to be at 1, now it's at -2. Now to find omega, we do it in a very similar way to the last time. So we look at like a peak to a peak. So let's say from -1 all the way to 3. That distance is 4 in length. So that t is equal to 4 for the period, which means that we need to figure out the value of omega by setting 4 equal to 2 pi over omega. Multiply each side by omega, gives us 4 omega equals 2 pi. Divide by 4, and we'll see that omega is equal to 2 pi over 4, which is pi over 2. So we'll put pi over 2x. And that is how you find an equation for a sinusoidal graph.